In today's video, we're going to talk about how to evaluate expressions that contain absolute values and different kinds of roots, particularly square roots and cube roots. So first, we're going to start with absolute value. So these two parallel lines are read the absolute value, and they're the symbol for the absolute value of a number. Absolute value is the distance a number is from 0 on the number line. Distance is always a positive number, therefore absolute value will always be positive. So for example, the absolute value of -9 is 9, and the absolute value of a positive 9 is also 9. If I were to draw this out on a number line, here's 0, here's -9, and you'll notice that if I jump the number of spaces or the number of steps it takes me to get to 0, there are 9 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9. Didn't draw enough lines there. Alright, same thing with positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's 9 spaces away from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so absolute value is the distance from 0. So first example, the absolute value of h, and h is 10. So this is going to be the absolute value of 10, which is a positive 10. Example 2, I have 3m plus 4, so the absolute value of 3m plus 4. We're going to evaluate this the same way. We're plugging in 5 for m. Remember, plug in using parentheses. So 3 times 5 is 15, so I have the absolute value of 15 plus 4, which is the absolute value of 19, which in fact is a positive 19. Example 3, I'm going to plug in -2 for k, so I have the absolute value of -2 minus 1. -2 minus 1 is a -3, so I have the absolute value of -3, and the absolute value of -3 is 3, so it's 3 spaces from 0. All right, last example, we put some fractions and mixed numbers in here, as well as some negatives. So first thing I'm going to do is change my fractions into, my mixed numbers into improper fractions. So I'm going to hold my negative sign for h. 2 times 2 is 4, plus 1 is 5. So I'm going to have a -5/2 for h. And for j, 2 times 3 is 6, plus 2 is 8. So I have 8/3 for j. And then I'm going to plug in. So h is -5/2 times the absolute value of 8/3. 8/3 squared. Again, plug in parentheses. Order of operations, absolute value counts like grouping symbols, so I'm going to evaluate on the inside of those first. When I'm squaring a fraction, remember I can square the numerator and then square the denominator. So I have -5/2 times the absolute value of 8 squared. 8 times 8 is 64. 3 squared is 9. Then I can go ahead and take that absolute value. So I have -5/2. The absolute value of 64 over 9 is 64 over 9. Positive. I can cross simplify. 2 and 64 are both divisible by 2. Okay. Then I'm going to pull out my calculator here. And I'm going to multiply straight across. So -5 times 32 gives me -160 over 1 times 9 is 9. And I cannot reduce. So my final answer, leave as an improper fraction, will be -160 over 9. All right, turning the page, we're going to talk about roots, both square roots and cube roots. A square root is a number times itself that equals a given value. Remember, when multiplying same sign numbers, the answer is positive. So for example, 3 times 3 is 9, so therefore the square root of 9 is equal to 3. We also, in this case, have positive and negative roots, because in addition to 3 times 3 being 9, -3 times -3 is equal to 9. So your positive root would be 3, and your negative root would be a -3. So we're going to write our answer as plus or minus 3. A cube root is a number times itself and then times itself again that equals the given value. the sign of the given number, and the simplified number will be the same. So 2 times 2 times 2 is equal to 8. Therefore, those little dots mean therefore the cube root of 8 is equal to 2. Negative 2 times negative 2 times negative 2 is equal to negative 8. Therefore, the cube root of negative 8 is equal to negative 2. We cannot take the square root of a negative number. So if I had the square root of negative 9, there would be no solution. However, I can take the cube root of a negative number. Cannot do it for square root, can do it for cube root. All right, let's check out some examples. So the square root of m when m is 16, this would be the square root of 16, and that's going to be plus or minus 4. Remember, 4 times 4 is 16, but negative 4 times negative 4 is also 16, so you want to make sure you include both of your answers there. If you have a multiple choice question like this on a test or an SOL, you would default to the positive answer and just put 4. But since it's a free response, you want both. All right, let's look at the cube root of 27. I want to think what times what times what gives me 27? And the answer is 3. 3 times 3 is 9 times 3 is 27. All right, next example, I'm going to plug in 3 for p. So I'm going to have 7 times 3 plus 4. And 7 times 3 is 21. So I have 21 plus 4. Taking the square root of 21 plus 4 is 25. And the answer would be plus or minus 5. Last example, I'm going to plug in 5 for x. I have the cube root of 4 times 5 minus 3 times 5 minus 2. Okay, 4 times 5 is 20. So I have the cube root of 20. Negative 3 times 5 minus 2. Parentheses. Cube root of 20. Negative 3 times 5 is negative 15 minus 2. Following that order of operations, going to continue to work inside the parentheses. So I have 20, negative 15 minus 2 is negative 17. So I'm going to multiply 20 times 17, and I get 340. So I want the cube root of 340. And then I have to think to myself, what times what times what gives me 340? So I know it has to be less than 10, because 10 times 10 times 10 is 1,000. We can try, not 6, it's bigger than 6. 6 cubed is 216. Let's try 7. It's 343. So there may not be anything. So you would leave your answer as the cube root of 340. And let me just double check my math again here. 4 times 5 is 20. Negative 3 times 5 is negative 15 minus 2. 15 times 2 is minus 17. Yeah, so you would just leave your answer in an unsimplified form.